to begin the course by introducing Chapter 1. Chapter 1 covers functions and graphs. In the first section of Chapter 1, we're going to specifically illustrate how to graph a particular equation. The equation that we want to graph is y is equal to the absolute value of x plus 1. And we're going to use the values of x, integers, between a -4 and 2. All right, so we're going to create a table. In order to graph any equation, we need a set of ordered pairs. So we're going to generate a set of ordered pairs. And we're going to choose x according to the definition here. So we have a -4. All right, when x is a -4, so we have, we're going to now compute the y coordinate. So this is the x coordinate, -4. To get the corresponding y, we need to substitute into this equation. So that's the absolute value of a -4 plus 1, which is the absolute of a -3, which is 3. So the corresponding ordered pair is the x coordinate is a -4, the y coordinate is 3. The next x value is a -3. So when x is a -3, we have the absolute value of a -3 plus 1, which is the absolute value of a -2, which is 2. The corresponding ordered pair is a -3, 2. The next x value is a -2. When x is a -2, we have a -2 plus 1 is equal to a -1. The absolute value of a -1 is 1. The corresponding ordered pair is a -2, 1. A -1. Now the x value of a -1. To find the corresponding y value, we have the absolute value of a -1 plus 1. The absolute of 0, a -1 plus 1 is 0. The absolute value of 0 is 0. The corresponding ordered pair is a -1, 0. 0. When x is 0, we have 0 plus 1, which is the absolute value of 1, which is 1. The corresponding ordered pair is 0, 1. When x is 1, we have the absolute value of x plus 1. X is 1, so this is 1 plus 1 is equal to the absolute value of 2, and the absolute value of 2 is 2. The corresponding ordered pair is 1, 2. All right, and the last x value is 2. So when x is 2, we have the absolute value of 2 plus 1, which is the absolute value of 3, which is 3. The corresponding ordered pair is 2, 3. We now have a set of ordered pairs. If we now plot the ordered pairs in the rectangular coordinate system, we will obtain the graph. Now that we have determined the ordered pairs, which are really points which would lie on the graph of the original equation. So we're going to now plot these points in the rectangular coordinate system. So now we're going to plot the points which would lie on the graph of the equation. So the first point or ordered pair is a -4, 3. X is a -4, y is 3. The next ordered pair is a -3, 2. A -3, 2. negative 1, 0. So negative 1, 0 is here. 0, 1 is here. 1, 2. The x-coordinate is 1 and the y-coordinate is 2. 2, 3. The x-coordinate is 2 and the y-coordinate is 3. All right, now that we've plotted the points to obtain the graph, we connect the points. So if we connect the points, all right, so this is the graph of the equation y is equal to the absolute value of x plus 1. In this example, we want to identify the x and the y-intercept given the graph of a function. As you recall, the x-intercept is the point where the graph crosses the x-axis. So it crosses at this point. All right. So the x-intercept is the point negative 3. And of course, the y-coordinate of the x-intercept is always 0. Also, you may recall that the y-intercept is the point where the graph crosses the x-axis, the y-axis. And we can see from this graph, that point is 0, 3. So the y-coordinate is 3. So the y-intercept, excuse me, the y-intercept is the point 0, 3. In the next example, we have a vertical line. The line crosses the x-axis at the point 4, 0. So the x-intercept in this example is the point 4, 0. We see that the graph, the vertical line, does not cross the y-axis, so therefore there is no y-intercept. No y-intercept. In the last example, the graph goes through the point 0, 0, the origin. So that means that x is equal to 0, or the x-intercept. So the x-intercept, all right, is 0, and the y-intercept is also 0. All right? In this example, we want to find the x and the y-intercept. All right, so given the equation, how do we find the x and the y-intercept? All right, so to find the x-intercept, let y be 0. So in the equation, 2x plus y is 0 is equal to 6. 2x is equal to 3. 2x is equal to 6. So therefore, x is equal to 3. So the x-intercept is the point 3, 0. The x-intercept. To find the y-intercept, let x be 0 and then solve for y. So in the equation, 2x plus y is equal to 6. Letting x be 0, we have 2 times 0 plus y is equal to 6. 2 times 0 is 0 plus y. So we have y is equal to 6. So therefore, the y-intercept is the point 0, 6.